Welcome back to the 5 Caillou series. This one's called Int32 to IPv4, Internet Protocol version 4. Take the following address, 128.32.10.1. This address has 4 octets, where each octet is a single byte or 8 bits. The first one has the binary representation, 1 followed by zeros for 128, right? This one is 32. This one is 10, and this one is 1. And so the whole thing, if you convert to binary, would look like this. Because the above IP address has 32 bits, we can represent it as the unsigned 32-bit number, this. Complete the function that takes an unsigned 32-bit number and returns a string representation of its IPv4 address. For example, you're giving that number that we just talked about. It returns this address. 32 would return like so, and 0 returns like so. I think that's pretty clear. You get a unsigned integer, meaning it's going to be not a negative value, and you're going to convert it to one of these addresses. Since it consists of 32 bits, there's no problem in this. Your input consists of 32 bits, so there is no sizing trouble. So go ahead, pause the video, have a go, and come on back. Okay, so to get started, my strategy, I'm going to convert the input that they give us into a binary form. And we've seen this where using a string, we can sort of make that conversion happen with some built-in behavior. So we can use the convert class to string, and then what you do is give the number, and then you provide the base for the numerical base that you want. Since we're going to binary, we're passing a 2 here. We're saying convert it to binary, and then I'm just naming my variable binary because it will represent the binary form of that number. Good. And so if you paid attention to the examples, you'll notice that it's possible we'll get something smaller, right, where it's not necessarily 32 bits. So what I mean by that is, consider we get the input 0 here, and I convert it to a binary string. Well, this string is going to look like this, right? It's just going to be 1, 0. And that's not really what I want. What I want is, I want 32 characters, even if they're all 0. So for that 0 input, you know, etc., I'd want it to be 32 zeros, because my plan downstream here is to grab these in groups of 8, each section, pull off 8 bits at a time, and make a corresponding numerical value for it. So to deal with that situation where when we make this binary conversion, it comes in as something less than 32 characters, I'm going to pad it with leading zeros, which shouldn't, well, it won't affect the value of the number if I just put zeros in front of it, right? If you have the number 137 and I just put 3 zeros on the front, it's still 137, right? We just don't do that because it's redundant. But that's what I'm going to do here. And I don't think we've used this method in this series yet, but string class has a pad left method, and it will return a new string that right aligns the characters in this instance by padding them on the left with the specified character, which is perfect for our uses here. And you can go down, this is the total width you'd want. You can guess that we want it to be 32, and our padding char or character will be a 0. They might even have an example here. They do, so if you want to look at that, feel free. Okay, good. So if you wanted, you could make a separate variable, bool needs padding equals 32 minus binary dot length, right? That'll tell us how many characters it has. If that's greater than 0, right, that means we need padding. Needs padding, and we can refactor this. I just try to do stuff by the numbers while I'm solving. If needs padding, right, then we know we have to do that. So we can say binary equals binary pad left, and we want it 32, and we want the character 0. Make sure you're using single quotes for characters, right? Not double quotes. And you'll notice from pad left, if you go to the returns part, it's going to give you the new string, so it's not going to change the original string. It's going to give you a new one, and that's why I'm reassigning this back to binary. I'm calling pad left on whatever was filled in here, and then that's pad left's going to return potentially a new value, and I'm just updating binary with that value if it needs padding. I think that's clear. Okay, so I'm happy now. I'm at a point where I'm guaranteed to have 32 characters. Good. So I told you I want to break these up into 4 groups of 8, and I'm going to do that. I'm going to make them as integers, 4 integers. And then sort of the idea being that then that we'll be converting these 8 character chunks into integers, and then finally we can just return those integers separated by a period. So let's do that. We can say int array octets equals new int array, and there's going to be 4 of them, size 8. And then I'm going to make an index here, just start at 0, because what I'm going to do is I'm going to make a loop. We're going to do this 4 times. Int I equals 0, I is less than 4, and then increment I. Nothing crazy, right? Okay, so we're going to do this 4 times with our binary to get what we need, and the job here will be to populate this octets array. So for that, what can we do? Well, what we're going to start by doing is grabbing the necessary substring from binary, right? And to do that, we provide the starting index, and that's why I initialize that to 0, right? And then you can tell it how many characters to grab, and it will always be 8, right? We're doing 4 by 8 is 32. So start, in this case, at 0, right? Index was initialized at 0, but I'm going to update index. I'll show you. We'll say index plus equals 8. And that will bump us ahead, so the next time we come through the loop, it'll be 8, and it will grab, it'll skip over the first 8 characters, and then since it's 0 base starting at index 8, will be the 9th character, and it will grab 8 more characters from there, etc. Okay, so binary substring, of course, this produces another string, and octets are integers. So I'm going to actually convert these strings into their integral values. And we can use the convert class again to int32 this time. And we can do that, and also note that the conversion is happening with binary. I think I got enough parentheses there. Looks like I matched up. Looks good. And then, yeah, so next time through index goes up to 8, next time 16, next time 24. And so when we get through this for loop, right, now octets is populated with 4 numbers. And then it's just a matter of sort of constructing the final result, which, if you remember from the method signature, was a string. They want this in a string form. So what I can do is I can say string join, remember join? You give it the character, the delimiter that you want to join things on. Often it's a space, but here it's a period, or oftentimes it's a comma too, but here we want a period. And then you give it the collection of items that you want joined. And I think this will cover us. I'll probably need to bring in the system namespace if it's not. Let's see how that goes. Okay, green is good. And green is good. Clear for takeoff. Now, yeah, like I said, we kind of did this by the numbers here. You don't need this extra variable. You can just take your condition and do that. You know, I did it the other way at first because it reads nicely. You understood right away what I was doing as opposed to just looking at this. It may not be so clear, but I'll leave it up to you if you want to condense that or not. So otherwise, I'll probably submit mine like this. Yeah, why not? Let's go ahead and do that. They're going to make me attempt again. No problem. Good. I'll go ahead and submit. And yeah, we're good. Nice and concise answers in here. So yeah, feel free to look through these as well. Otherwise, hit me up with your questions and comments. I appreciate you watching, and I'll see you in another video.